CRD 5.1, completing the square. CRD 5 is when all of algebra comes into focus. All the things you've learned come into play here, which is pretty exciting. Maybe not all in 5.1, but in the whole chapter 5. It's my favorite chapter of all the series, and I hope that you agree. So let's talk about what the whole point of this is. Completing the square is one way to solve a quadratic equation. So if we look at what we did in Jousting Armadillos, we learned how to solve a linear equation. So this is like my Jousting Armadillos section. We had an equation like this, and we were trying to figure out what x was. We subtracted 1 on both sides. We got 2x equals 10. We divided by 2 on both sides, and we got our solution x equals 5. That was Jousting Armadillos. Then in Coconuts and Crocodiles, you still dealt with linear equations, but this time they had 2 variables in them. So something like this. And the only way we knew how to show the solutions to this, because they were infinite, was to graph our y-intercept, a slope of 2, and basically create a line like that. It was a straight line because it was a linear equation. We did talk a little bit about parabolas and hyperbolas, but the main focus of that book was learning how to graph a linear equation. Now, in Chuckles the Rocket Dog, we've been working with quadratics. Okay, quadratics, of course, is when x is squared. It's the degree of the equation. And the first thing we're going to try and learn how to do is how to solve this. What does x equal? Well, you have learned in CRD 3 how to solve this. What you were told or learned how to do is that you factored that trinomial. Remember, 6 plus 1 equals 7. 6 times 1 equals 6. And then you said if both of these multiplied together equals 0, I'll use the zero product property and say, well, x plus 6 has to equal 0, or x plus 1 has to equal 0. And when I solve for that, I get -6 or -1. And of course, if I plug in -6 in here, I'll get 36 minus 42 plus 6 equals 0. And if you do that math, you will see that works. If I plug a -1 into the equation, I'll get 1 minus 7 plus 6 also equals 0, which it does. So I have 2 solutions. Okay, that's what I learned in CRD 3. I also learned that if I were to graph this parabola, it would have 2 solutions, one at -6 and one at -1, and it would be a parabola, which that's not perfect, so bear with me on that. But the 2 x-intercepts were the 2 solutions. Okay, cool. Well, that's what you know already. So here's the problem. Sometimes you're going to have a quadratic equation and it won't factor. If I look at the factors of 6, I have 1 and 6 or 2 and 3. But if I add 1 and 6, I don't get 6. And if I add 2 and 3, I don't get 6. So this is a prime trinomial. So it doesn't factor. So I can't use my zero product property. So I have to come up with another method because there actually are 2 solutions to this equation. So what we're going to learn in this chapter are the 3 methods of solving a quadratic equation. The first one I just reviewed with you, factoring method with the zero product property. That's a favorite of mine. It's usually the easiest, but it doesn't always work. This will be included on your tests and quizzes because this fits in with this chapter. So do know that you will need to remember how to do that. Completing the square. So that's where we are now. We're going to take something like this and we're going to learn how to complete the square. And that's going to be a method of solving a quadratic equation. In 5.2, we'll learn the quadratic formula, which also is very, very fun. Okay, next. Before we get into the process of completing the square, I just want to show you one notation. You're going to get 2 solutions most of the time when you're solving a quadratic equation. So you might go through the problem and end up with an answer that looks like this. X equals 8 plus or minus 7. So that right there is called plus or minus. And it's just because mathematicians are a wee bit lazy. They don't want to do 8 plus 7. Oops, that's very messy. Sorry about that. Let's see if I can do that again. They don't want to do 8 plus 7 and 8 minus 7. But that indeed is what they are trying to do. I'm in trouble with my pen. So 8 plus 7 would give you x equals 15. And 8 minus 7 would give you x equals 1. Okay, here is a little trickier, 7 plus or minus root 7. Well, root 7 doesn't simplify anymore. What the answer here is 7 plus root 7 and 7 minus root 7. And I could write that too, but this is a lot easier. Root 7 is very close to what? Root 9? In between root 9 and root 4. So it's in between 3 and 2. In fact, probably right in between. So really my answer here, if I were to estimate it, would be 7 plus or minus 2.5 because root 7 is between 2 and 3. So really this one is x equals 7 plus 2.5, 9.5, or 7 minus 2.5, 4.5. And it's approximate because root 7 is not exactly that. Okay? If you were to approximate this one, you would have x is about equal to negative 6 plus 2 times, well, root 37 is close to 6 because root 36 is 6. So basically, negative 6, I'll do plus or minus 12. So negative 6 plus 12 would be 6. Negative 6 minus 12 would be 18. So my answers are 6 and negative 18 approximately. Realistically, you're going to leave your answer like it is in these two. This one here, you would actually write 15 and 1 just because it's a whole number. But these two, you would leave your answer in simplest radical form. Okay, another thing you need to know is a binomial squared. What does that mean when I say that? And what does it mean a perfect square trinomial? Binomial squared are these. It's a binomial, x plus 5, squared. X minus 9 squared. Well, when I actually square these, I will get a perfect square trinomial, which are what these are. So let's take a look at it and see if we can see a pattern. X plus 5 squared equals x squared. First of all, you have to remember that this is x plus 5 times x plus 5, right? So what happens when you multiply that is you get x squared plus 10x plus 25. And there is a pattern on these to make it easier. So if I look at this one, remember your brain should be thinking x minus 9 times x minus 9, and I get x squared minus 18x plus 81. Notice that x plus 5 squared, if I double the 5, I get 10. If I square the 5, I get 25. If I double negative 9, I get negative 18. If I square negative 9, I get positive 81. So these are my perfect square trinomials, or PST. Now, if I'm going to go backwards, I know I'm telling you this is a perfect square trinomial, so you know it will factor into something that looks like that. X. And remember how we had 5 squared was 25? So what squared is 16? Oh, 4. 4 doubled is 8. 4 squared is 16. So this, when factored, is x plus 4 squared. See if you can figure out what this is when it's factored. X minus 3. Negative 3 squared is positive 9. Negative 3 doubled is negative 6. Okay, so hopefully that's clear to you. Now we're going to actually complete the square. So completing the square to solve a quadratic. I'm going to go through the whole process, and these are the steps. And I think I have 3 examples, so I would write down probably 1 in your notes to self. You don't need all 3. Okay, this was the problem I started with at the beginning. X squared plus 6x plus 6 equals 0. Step 1. Force the left side to become a perfect square trinomial, PST, by adding or subtracting numbers to both sides. So I want this side here to become a perfect square trinomial. I know x squared plus 6x can be 1, but 6 is not the right number. So I actually want this to say plus 9, because remember, if I double 3, I get 6. If I square 3, I get 9. So now I have a perfect square trinomial, but I changed it from x squared plus 6x plus 6 into x squared plus 6x plus 9. So what does it look like now? That's still not accurate. Actually, I missed a step. I have to add numbers to both sides, not just to one side. So what I did was I added 3 to get 9, so I have to add 3 to this side. So basically That's what I did to both sides. Okay, check, I did step 1. Now it's a perfect square trinomial. Step 2, factor into a binomial squared. So if I take this and I factor it into a binomial squared, I get x plus 3 squared. 3 plus 3 is 6, 3 times 3 is 9. Okay, all I did was factor this side, it's still equal, so 3 on this side is going to just stay 3. I didn't do anything to it. Step 3, square root both sides. Okay, if I'm going to square root this side and I'm going to square root this side, I can do that to both sides and it won't change the equation. So when I square root something that's squared, it becomes x plus 3 without the squared. When I square root this side, I can't actually square root 3 without getting an irrational number, so I'm going to leave it as root 3. But because I'm square rooting this side, I'm not sure if it's going to be the positive root or the negative root, so I'm going to write the square root plus or minus the square root of 3. Don't forget the plus or minus sign. It's really easy to forget that. Okay, so I've done that one, I've done that one, I've done that one. Step 4, solve for x. Well, that means I need to get x by itself. So I'm going to subtract 3 on both sides, and I'm going to get x equals negative 3 plus or minus root 3. Okay, step 5, simplify any fraction or any radicals. You should get 2 answers most of the time. So can I simplify root 3? No. I can't really do anything else. I don't have any fractions or anything. So my answer is x equals negative 3 plus root 3 and negative 3 minus root 3. And if I were to estimate this answer, although you're not asked to do this most of the time, but just for fun, if we were to estimate that answer, it would be something like negative 3 plus or minus 2, 1.8 maybe? Not quite 2. So negative 3 plus 1.8 would be 1.2 negative, and negative 3 minus 1.8 would be negative 4.8. Okay, here we go. Another example. Step 1, force the left side to become a PST. Well, this one only has x squared plus 12x, so I'm going to leave the negative 32 over there. If I want to get that last term, I have to think about half of this, which is 6, squared, 36. And of course, if I added 36 to this side, I have to add 36 to this side so that it keeps it balanced. Okay, great. Step 2, factor into a binomial squared. Check. All right, x squared plus, what number goes here? When I factor this whole side, what number goes here? Well, it's going to be half of 12. 6 squared is 36. 6 doubled is 12. This side, I actually have to do the math. 36 minus 32 is 4. Okay. Step 3, square root both sides. Don't forget the plus or minus sign. Ooh, that got messed up. That moved out of the way. That's okay. X plus 6 equals plus or minus root 4. Okay, check. Solve for x. Minus 6, x equals negative 6 plus or minus root 4. Done. Step 5, simplify any fraction or any radicals. Well, the square root of 4 is 2. So, negative 6 plus or minus 2, which gives me an actual answer, not an estimate. Negative 6 plus 2 is negative 4. Negative 6 minus 2 is negative 8. And those are my 2 solutions. Okay? One more, and this is the hardest one you'll get. This is number 47. This is a little harder because the perfect square trinomial has a leading coefficient. So, step 1, force the left side to become a perfect square trinomial. Well, when it's harder for me, what I like to do is I like to move the 6 over here by adding 6 to both sides and then leaving a blank here because I know that I'm going to fill in the same number on both sides, but I have no idea what that number is right now. So what I do, and again, when it's harder, is I really draw it out. I know this and this have to be the exact same thing for it to be squared. I know it's going to have to be 4x and 4x because that's how I'm going to get 16x squared. My middle term has to give me 16x. So I know it's plus and plus because there are only positives. And I want to think about what number times itself gives me this number right here. But also my inners and my outers are going to multiply together, then add and give me 16. I actually get a 2 because then my inners give me 8x, my outers give me 8x, so I get 16x, and then 2 times 2 is 4. So I'm actually adding 4 to both sides. Okay, that's the hard step in this one. Step 2, factor. I already did, but just to write out my work. And then I'm going to add 6 plus 4 and get 10. Now I'm going to square root both sides. And I can't forget the plus or minus sign, even though I didn't write that there. There we go. Solve for x. I subtract 2. I get 4x equals negative 2 plus or minus root 10. I divide by 4. And I get x equals negative 2 plus or minus root 10 over 4. Now, step 5, simplify any fraction. There is some simplifying that has to be done here. Root 10 you can't do anything with, but, oh, actually, no, I can't do anything with. There's no simplifying I can do here because root 10 and negative 2 and 4 have to all have the same factor in order to reduce. So this is the answer of how you will have to leave it. This is the answer. I'm going to show you one more thing. Oops. Okay, before you listen to my last note here, I do want to show you something about simplifying, and this does come up in Linus's lesson, so I'll move this down here. If you're going to simplify something, let's say you get your final answer looks like this. Try this again. This comes up right in the beginning of the lesson, I believe. So you have negative 2 plus or minus 4 root 10 over 6. Okay, I look at root 10 and I can't reduce that. But what I see here is that this term, and this term all have a factor of 2 that I can take out. So if I basically divide each one of these by 2, I will get negative 1 plus or minus 2 root 10 over 3. That's the most I can do to reduce that fraction. It's not the answer to the last question we did. I just made this up so I could show you how to simplify that. You can ask me in class if that step's a little bit tricky. Now, do problems 1 to 49 in the book. Then watch Complete the Square Part 2 video and add that one to your notes to self. That's kind of a different skill that I want you to practice after you've learned how to complete the square.